Alrighty, hello everybody, welcome back to the channel. Today we're actually going to build a 3D compass. So, I'm just going to go over the theory and then we'll build this. The theory is quite simple. What we need are our inputs. We need our X, Y, Z. We want to know where we're going, X, Y, Z. And that's it. And then what we need to do, to go from point 1 to point 2 on an X, Y, Z, we need to minus the second X, Y, Z from the first X, Y, Z. Then we need to square that. And then we need to find the square root of all those numbers combined. And then we can take that square root and we can use that to further give us the rest of the equation. All right? So that's basically what this does. So then what we do is we bring it into a Lua script. We graph it. Okay, so that's what we're going to do today. We're going to bring it into this Lua script. We graph it. And then we print it. So, it took me a little bit to figure it out. I tried to get the website that I was looking at last night. Yes, in the middle of the night, my brain says, hey, let's build a 3D compass. Okay, so that's what I did. So what I did is I just went to Google and I was like, how do I go from point 1 to point 2, X, Y, Z? And I got the formula. So then I had to think about, okay, how do I build the formula with the logic? And then I went to space. So that's this right here. This is our 3D compass. Pretty neat, huh? You see how it's doing what it's doing? So basically what we're doing is we're finding the slope to each angle. And then we're basically making like a sphere. Okay, the sphere is 16 pixels. It's the size of one of these. And yeah, I don't know, I guess there's no easy way to describe it. Like I say, I was on Google and I was searching the internet here to try and find what I was looking at. And I think it was really simple. There was two explanations that were really was it stack overflow? Yeah, here we go. I think this was it. This was it here. So this is the first one. The first one was really confusing. Oh, this was just the X, Y. We don't want that one. We actually want it was okay, so maybe if it was Stack Overflow, I think I already had that come up. I was here. Yeah, anyway, so if you're looking for how to do things, just type it in, then you get all this fancy stuff, right? Here's some math. We're talking about Euler angles again, right? All this fancy stuff, this stuff here. So anyways, I had it, it's probably on my phone. Yeah. It'll make more sense once we build it. So now we're actually going to build it, and I have I'm going to build it on the spaceship here, but it doesn't matter where you build it. You can just build it. All right. So we can do, for example, on the logic, we can have our compass in. Okay. This is going to be the astronomy sensor. So I'm going to do this a little bit better, and then this is going to be our ship, no, moon, or whatever, destination X. Let's see, destination Y, destination Z, destination Z. Which one's that? Destination. Alright. And the astronomy sensor. So we need two sets of X, Y, and Z. So now if we go to our composite here and we go over to the astronomy sensor, now it gives us our X, Y, and Z position in meters, and that's 1, 2, and 3, Earth to sea level. So we need composite read number. And we have to split the channels. Channel 1, channel 2, channel 3. That is our XYZ ship, XYZ destination, where we want to go. All right, so now what we need to do is we need to individually take X2. So we need to subtract here. X2 minus X1, Y2 minus Y1, Z2 minus Z1. So this is going to be A. All right, and then what we need to do is we need to square that. So we need to multiply the finished number by 2. So we need a constant number, and we're going to change the constant number to 2. All right, now the sum. So now what we need to do is we need to add them all together. All right, so now the sum of all of this math, what we need to do is we need to get a function block, and we need to now find the square root of the sum. So to do that, we can do right here, square root x just like that. So now that we have the square root, we can use that value, the rooted value, to find the slope of all the individual values, the slope of x, y, z. So now what we need to do is we need to take this value here, we need to divide it. Okay, so what we need to do is we need to take x1, x2 minus x1, not the squared value, just the regular value, and we need to divide that by the square root. And that finished value is going to be our slope. Oh, sorry, we take this value here, and then we divide it again. And that becomes a slope. Let me double check this here. Uh-oh. I actually didn't divide it again. On here, okay. Oh, that finished value, yeah, has to be divided again. This is our slope here, x, y, z. Whoopsies. The top number divided by the bottom number. Yeah, there we go. Okay, so now what we need is a composite right number. And we'll run that into our Lua script, and then we need 5 channels. We have our X, we have our Y, our Z, and then we need 2 constant numbers, which are going to be our radiuses. Or our screen width and our screen height. I just find it was easier for me to write the code this way. Okay, so the first thing we need to do is we need to get the values. So I did X, Y, Z. And then we need W and H. All right. 2, 3, 4, 5. Just like that. All right, so now what we need to do is we need to take our slope and we need to convert it into an angle. So to do that, we need we'll say we need to say x times 360 times math.pi divided by 180. I think I forgot one conversion here. Oh, I did, yeah. So to get the angle, we need to take the angle and we need to multiply it by tan. So let me show you what I mean. I kind of went skipping ahead a little bit here. Let's go and look at the other. Yeah, right here. To convert it into an angle, you have to take a tangent and you have to multiply it by the slope that we were given. So, before we do this part here, before we convert it into degrees, we need to convert it, we need to find the angle. So, and then we need to say, I think it's math.tan, and we need to multiply that by x. This is that number that we were given, the square root of the square root of the square root. So that gives us the angle. And now what we have to do is we have to convert that angle into degrees. So that way we can print it. Because to print it, we need the xy. We need the xy to know where it is, right? x1, y1, x2, y2. All right, so now that we've done that, we can now, we need x1 and x2. We need y1 and y2. And we need z1 and z2. So we need 3 sets of coordinates. How do we do that? Well, x is going to be our width divided by 2. And then we're going to add the radius, which is, in this case, going to be 16. Because the screen is 32 by 32 pixels. All right, and then we're going to multiply that by math.cosine. Then what we need to do is we need to say 1.58. Now what is 1.58? That is 1 degree of 360 degrees. So every time the line on the screen moves, it's going to move by 1 degree. Now we can double this to 306, and then it'll move by 2 degrees every time it spins. So that's how you can change how you want it to spin and that kind of stuff. That's a little more complicated. Okay, and then what we need to do is we need to add the angle, just like that. Now this one here is our height, and it's exactly the same. Let's see here, we'll do this. That's our Y, and that's our Z, just like that. So now why does that matter? Well, if we want to draw a line, we need an x1 and an x2. This is our 3 lines. So now I can draw 3 lines. And they're going to go from let's see. W divided by 2 to x1, and then we're going to say h divided by 2 to x2. This is our width, this is our height. This is our, oh no, sorry, we need an x1 and a y1, which is the center of the screen. And then that's going to go to x1 and x2, our angle. Perfect. So now we should have 3 lines. So now what I'm going to do is I'm going to add a video output. Output, video. The last thing we need to do is we need the XYZ from the ship. So take our linear X, and our linear Y and our linear Z. Linear Z. Linear Y. All right. Take our video. This compass will be a little more accurate than the other one because it squares it double squares it instead, so it'll be more accurate. All right, let's save that. I'll spawn it in. Oh, whoops. I wrote the code wrong. I said get bool. Should have said get number. All this has to be changed. Bool is on off. Perfect. Now there's only one line. Why is there only one line? Well, because I didn't change this over. No, like I say there, this needs to be Y and Z and Z. Okay, and so now what we can do is we can set a custom color for each of them. All right, so let's go. I'm just gonna look at what color I had here. Let's see. X is red. Let's go back in there. Which is 25500. And Y is green. Let's read it here. 01280. And blue is Z. 00255. All right. Save that. Spawn it in. Let's find that dog. All right, so turn on the systems. Let's see here. Linear X is going to be 14988. Linear Y 490 166. Oops. Something is a little awry with the line. Let's check the calibration. All right, I just want to check the other Lua script there. Oh, I spawned by accident. I hate it when I do that. Oh, I see. X1 to Y1, X2 to Y2, X3 to Y3. I think that's what it is. Yeah, because this could be Y1. This could be X2 to Y2. And this could be X3 to Y3. Really? Same thing. Same thing. Circle's too big. All right, let me check that I have. Yeah, that should be right. It's this here. It's this here that's got me a little bit confused. I think this is wrong. This here is going to be, I was going to give us a fraction. And this is what we want. We don't need to continue to, this is our slope here. So X, Y, and Z. This is our fraction that we want, I'm pretty sure. I'm pretty sure. I don't know why I doubled down there. Okay. All right, come on, dog. I guess if I wanted to convert it over from a fraction. But then, yeah, there's a little bit more math involved in that. So, there we go. Just something. Hold on. Still something a little off about that. It just doesn't look like the first one. Let's see what's going on. It's a printing mistake. But what is the printing mistake? I already have it here. So I guess I don't need that there. Oh, I need it for here. Oh, that's why. There's two Y2s. Aha! Well, that's confusing. No wonder. I'm like, why is it giving me the same? You see that? There we go. All right, now we're ready. So yeah, so let's just go over that real quickly. So these are numbers. These are all numbers. Why do we need the width and the height? Because we're actually using that to convert. So what we do is we take the raw number, our slope, and then we do tangent slope. That gives us our angle. Oh, and this needs to be this needs to be like that. The angle. So this is our slope. We multiply it by tangent to give us the angle. We then need to take the angle and we need to convert it into degrees. So we do that. We multiply it by 360 and then we divide it using math pi 180, and that allows us to turn it into a flat compass. And then what we need to do is we need to say, okay, now I want to graph that compass. So I need an X and a Y value. So we're going to go from the center of the screen as far as 16 pixels over and up. And then what we need to do, oh, and then this is wrong as well. This needs to be sine. This needs to be sine. All right. Cosine for horizontal, sign for vertical. Then what we're doing is we're going to take math.cosine, math.sine. Cosine and sine. And this is our angle, and then we say, okay, at that angle, move by 1 degree. Easy peasy. All right, now it should work. Now it should work. Now it should work. That's it. All right, that's our final. We're going to space now. All right. That's the problem with copying and pasting first thing in the morning. Let's go. All right. We have 3 different lines, but two of them are still green. It works now. I just want to make the 3 different colors. It's so funny. The game's already slowing down. It's like, hey man. Okay. Something's going on here. X. Y is green. Which is actually 255. But X is supposed to be red. I think that's right. Yeah. Whoopsies. Let me check the color color. Yeah. Yeah. Perfect. All right, now we're gonna go. I just had to change the color to red. So we'll have 3 different lines. We'll have a red line, a green line, and a blue line, and those are going to be our X, Y, Z. Excellent. So we're going to add our linear X. We then need our linear Y. And then we need our linear Z. And of course, this is all in meters. All right, and that's our compass. That is our X, that is our Y angle, and that is our Z angle. And it's pretty much that simple. So when you're in space, if you can get all of those lines into the center of the screen, all right, let's see. Oh, I should make sure. There we go. Now I can just do an easy takeoff. I really need a spotlight on the front of this thing. See how that's changing? Holy, the wind is just throwing me around. Oh. There we go. 3D compass. See that? As the number slows down, that's the red line that we're crossing. So neat. So yeah, that's how you build a 3D compass. So then if you if you just wanted to track your Y, you can do that. You know, maybe have a toggle there where you can have 3 different screens, which give you each 3D, but that's your angle. Basically, that's the angle. The angle to X, the angle to Y, the angle to Z. So when it's being all crazy like that, that's where we're in almost direct alignment on Y. I think it's the coolest thing ever, to be honest. Real simple. What I'll do is I'll slow down in space and I'll rotate around. hard to. But now we have a vector. You see, now we have a vector that we can track. So now what we can do is we can actually take that output. Oh, I see that. I was almost exactly on our trajectory to where we needed to go. That's so funny. Yeah, but we can then take that trajectory and we can plug that into the rockets, because now we have our pitch and our yaw for the rockets, which is our X and Z. This is our yaw, right? Z negative, Z positive, X positive, X negative. And that is how we would be able to navigate in space. All we need is one of those points. So when a rescue mission comes up and it says go to this XYZ, we can plug in the custom XYZ and run that to the compass, and then we can have two modes, and then it will show us our angles of where we want to get to. The most important angle being green. That's our distance, that's our linear, right? So that would probably be the one that I would track the most. So long as you're good with that angle, you'll be able to get to wherever you're going. It's kind of wild. So now the next thing with the compass, obviously, is to try and put some other navigation. At this point, I don't even know. That's as far as it goes for me. But I would assume we need to add some information onto the dial. So you could print this number, and you could print this number if you wanted to, the distance to the XYZ here, so you can see it. Oh, we already have that here, actually. Here, look, we just went past our Z. And now it's gonna, let's see here. Yeah, it's pretty interesting. So you have to think about this as like a globe, a three-dimensional globe, and this is in the center of that three-dimensional globe. And what we're doing is that line is spinning around inside that three-dimensional globe, right? We're in the center, and these are our Euler angles. So this is how the ship is rotating out here in space off of this center. So what we need to do now, because we don't have a determination of our distance, that's why these things are being wild and they're not absolutely tracking. Now what we need is to add the distance in there, so that way we draw the line with the distance, and then we can be, maybe, I'm not too sure actually, I'm not too sure on that, but at least there we have the 3D compass, and this is just showing us right, because it's spinning on our, it's so weird, huh? This is our actual rotation, but I don't know if it's off. Here, let me see if there's any. Oh, there we go. Yeah, you see, when we are on our exact trajectory, it goes all wild and crazy. Because you have to think, our linear speed. Oh, we're going backwards at 195 meters per second. And then we have, or kilometers an hour, I think that is. I'll check. It's one of the two. Either way, we're moving fast. We're moving fast on our X, on our Y, and our Z. And that's why we're getting, it's throwing us all around, right? Because it's saying, look, if you continue at this speed, at this trajectory, this is the angle that you're going to have to follow in order to get to your destination, if that makes sense. So the closer we get to our destination, the less wobble we're going to get on these other parts. Like, you see that now we've stabilized a little bit here. So if I turn on the rocket thruster, I just want to try and get some forward momentum. There we go, starting to catch up. Alright, so I've activated the rear stability thrusters. Yeah, so we will slow down here, and then what I'll do is I'll turn on the reaction wheel. I can't remember which way these had to go. Let me see. This one here has to go like this. This one had to go like that, is that right? I'm just trying to slow us down here. Almost, and you see we're of course we've flown past our we're too far. Maybe this needs to be -1 as well. Why are we going backwards? Well, I just want to see if I can sit here and That one is definitely -1. Alright, this thing is loud. Well, I have to figure out these reaction wheels again. But as you can see, there we go. You see that? We're moving around a lot, obviously. But as you can see, we're almost, have an angle of, I just want to just showing the compass, that's all. Just showing that it is pretty accurate, right? So yeah, so that's how that's how all that works. And then of course we fall right off that. See? I think it's pretty cool. Maybe this is where the degree. I'm going to load this here. This is where the degree aspect works. So what we're doing is we're telling it to turn by 1 degree every time, and that might be too sensitive for space, right? Maybe we wanted to turn at 10 degrees, maybe something like that. Given our speed and our trajectory, maybe 1 degree is just far too accurate. If we were landing, we might want that to within a degree, right? So I just kind of just something like that. So that's where we'll take a look at it right now. If that was going too fast, spinning too fast, we can double this. So we can say 3.06, and now it's going to go every 2 degrees. I won't take off. I'll just sit down in it and we'll see that it'll spin, but it shouldn't be spinning. It'll be spinning a lot slower than it was. Oh, it should be 16 actually. I'm an idiot. Whoopsies. Should be 16. 8 plus 8 is 16. All right. There. You see it's rotating a lot slower? A lot slower. And maybe that's what we need to do, just to dial down the sensitivity of the compass. And so that would be for you to figure out. You can come back in here and you can say, okay, well that was pretty good. We could double that to 6.32, and then it's 4 degrees. And that might be a little more stable. Yeah, I guess I really wanted to get this out. The 3D compass was sort of the last thing, so it's going to be a little bit before I put out another Stormwoks video. But thank you all so much for watching. Just put that one on. Yes, there you see. And now we're only, based on where we are, we're only 2 kilometers. So that's, what is that? X is 1498. Y is 490166. You need to have all 3. I'm going to say minus 1. There we go. Now it shouldn't flip around so much, and it should be able to give us a more, because we're just measuring our rotation, right? The ship is in the center of that, and these are our axis that we can rotate on. Our y-axis, which is the length of the ship. That's this one here, the length of the ship. And then our x-axis, which is our this way. And then our y-axis, which is this way. While we're in space, because we're traveling straight up towards the moon. So that's how we pivot when we're heading towards the moon. And that's what this 3D compass here is showing. Those are our Euler angles. And so as we spin, the entire compass spins, right? Because we're also getting our, from the astronomy sensors, helping give us that. So this is a 3-dimensional representation of this here, basically. Right? These are our 3 angles of rotation. We're then taking that and we are saying, okay, take that rotation. I want to go from here to the moon. How do I need to rotate on which axis? And it's saying you need to rotate this way to get there, to get to your y value. You need to rotate this way to get to your x value. And you need to rotate this way to get to your z value. Cool, so that's going to do it for today's video. Thank you so much for watching, and I'll see you in the next one.